Hello, HSC 110, Medical Terminology and Body Systems. This is Dr. Teresa, and in this video, we will be discussing Chapter 4 on membranes and the integumentary system. So let's first dive into the concept of membranes. Epithelial membranes will provide linings for internal and external surfaces. If you recall in Chapter 3, we went over the different tissue types. Epithelial tissue, meaning that we have a particular type of cell, and we categorize those cells within the epithelial category by their shape and their number of layers. We find this type of tissue on the inner lining of organs as well as the outer covering of organs. So internal and external surfaces, or the lumen or the cavity of an organ, as well as the outer surface of that organ. We will find in an epithelial membrane that we will have this layer or sheet of epithelial cells, which will form the tissue, and then it will have a layer of connective tissue that it's anchored to. We have three main types of epithelial membranes, and they are mucous membranes, serous membranes, and cutaneous membranes. Within that mucous membrane category, this is where we find a layer of epithelium on top of a layer of loose connective tissue. And if you want to refer back to your Chapter 3 to get your head wrapped around, again, what loose connective tissue is. Within a mucous membrane, there has to be an element of moisture. Also, within these, there is almost certainly the presence of what is called a goblet cell, which is a unicellular gland that has its entire function almost in that of the production of mucus. Now, the purpose of mucus is to, yes, lubricate, but also to trap dirt particles and pathogens and have it be able to be more easily removed from the body so that it doesn't get into the deeper layers of the body. In a serous membrane, we will see that it has an outer layer of the simple squamous epithelium on top of a layer of loose connective tissue. Again, simple squamous. Simple means one layer, squamous means flat cells. So in this type of epithelial tissue, due to its shape and layering, we're going to see that the rate of diffusion is able to happen way faster. Because it's thin, it's small, it's flat, it's smushed, things need to move across this type of membrane quickly. In our cavities, we will see serous membranes in a double kind of lining. This type of membrane, for example, if it's around the heart, would be part of the composition of the pericardium. Now, the serous membrane that surrounds the heart will have a layer of this type of tissue that comes right in contact with the cardiac myocytes or the cardiac cells. This is the visceral layer of the serous membrane, and then it will have a space filled with serous fluid, a fluid that is produced primarily to reduce any friction from just inherent movement and metabolism. And then it will have this outer layer of this serous membrane, which we call the parietal layer of this pericardial tissue, that will help anchor the heart, in this case, to the body wall. So the parietal layer of any serous membrane will anchor it to the body wall, whereas the visceral layer comes in contact with whatever organ we're talking about. Now, I already mentioned serous fluid, again, primary purpose that we think at this point is to help reduce friction. It would have to do with probably heat dissipation as well as cushioning and protection as well around the organ. Within a cutaneous membrane, this tells us cutaneous that it's under the skin. This type of membrane will be comprised of a stratified squamous epithelial tissue over top of a dense fibrous connective tissue. So stratified squamous is multiple layers of flat cells. Within the cutaneous membrane of the skin, we will find sweat glands. This is more of a dry membrane in comparison or contrast to that mucous membrane and the serous membranes. When we discuss synovial membranes, these types of membranes comprised of particular tissue types and layers are almost all connective tissue. So once again, if you need to reference back to your chapter 3, where we discuss different tissue types in the connective tissue category, you can look there to kind of wrap your head around that maybe a little bit better. The line, there's a line, the capsules that surround the synovial joints are tendon sheaths and bursa. So these types of membranes we find associated with certain types of joints called synovial joints. They will secrete a fluid also, and it is known as synovial fluid. Now, we mentioned previously within that serous membrane, the production of a serous fluid. In this case, synovial fluid likely composed similarly. And again, its function is going to be for cushioning protection, heat dissipation, nutrient exchange as well, and reduction of friction. So here's an example of a synovial joint in your body, one of them being the knee. So we can see that this joint has been cut open and how this kind of works. The synovial joint itself has an encapsulation formed by what's called the articular capsule, and that's created by other types of connective tissue, tendons or ligaments, holding things together, and it will surround this joint, holding the fluid in place, as well as other structures. Now, the integumentary system, let's get into that. The integument is your skin. It is known as a cutaneous membrane. It has within it sweat glands and oil glands, which are different in their composition of product. Also within the integument, we have accessory structures of nails and hair. The integumentary system primarily has the function of protection. It is a protective cover of view. It is the first line of defense, comprised heavily of a substance called keratin. Also within it has cells called melanocytes. These melanocytes are responsible for the production of a substance called melanin. Also, within your integumentary system, you're constantly producing what's called insensible sweat. You're sweating all the time. It produces a level of fluid on the surface of your skin. And we call this the acid mantle. The acid mantle has a pH somewhere of between 4 and 6. So this helps with that first line of defense. Within the skin's or integumentary system's outermost layer, which serves as our water barrier, both coming into the body as well as leaving the body, it contains all of us. There is a protein substance called keratin. We've all heard of keratin. The skin's outermost layer contains keratin. This is a tough protein that we find concentrated in the hair and the nails, as it adds structural strength. It also helps protect the skin against damage from harmful chemicals. Keratin and naturally occurring oils will serve as a barrier that ensures that water does not escape or enter the body through the skin. The skin substantially lessens the evaporation of water and the essential molecules that water contains from inside the body. Keratin will also prevent water from entering the body during bathing or swimming. The skin is also extremely important in regulating body temperature. This is due to the extensive array of tiny capillaries and our sweat glands that lie near the surface of the skin. The capillaries contain blood, which circulates through the body. When the body's overheated, the capillaries will dilate or expand. This will bring more blood near the surface of the skin. The blood will cool as it nears the skin's surface, which dissipates body heat. So one thing you have to understand, that due to the water composition of blood, it is a great conductor of electricity as well as heat transference. So let me give you an example of that. And this is more of the circulatory system than it is of the skin, but it's relevant here because of how the skin gets to dissipate or take that heat via the circulatory system away from the core. So for example, females tend to be more cold in their fingers and toes and extremities. This is because the female has to maintain or regulate her core temperature fairly well and constant in case she would have a fetus on board. That makes a ton of sense. So also why we want to keep the core regulated. It will pull or shunt blood carrying that heat from the extremities, from the surface of the skin back to the core to keep that regulated, and vice versa. During hot conditions, the sweat glands then will become active. They produce sweat that evaporates and has a cooling effect on the skin. When the environment is cold, the capillaries will constrict or tighten, and then the blood flow will move to the deeper vessels away from the skin to minimize heat loss. Skin is also involved in certain chemical processes in the body. Specialized cells in the skin, known as melanocytes, produce a chemical called melanin. This is a pigment that protects the body against UV light. Exposure to UVB rays causes the skin's modified cholesterol molecules that we call provitamin D, really relevant, to convert into vitamin D. Vitamin D is essential for health across the board. Yes, we hear about it when we talk about bones, but as we get into the skeletal system, you'll see that how much bigger that actually is and how dynamic that system is. In addition to the process of sweating, the body eliminates chemical waste products, including urea, uric acid, and salts. Because the fluid secreted by the sweat glands is acidic, it also helps protect the body against bacterial infections. Finally, the skin contains cutaneous sensory receptors that are part of our nervous system. These receptors will transmit nerve signals that contain information about the environment, including touch, pressure, vibration, pain, and temperature. What I want to point out there is that your sensory system, only a very small portion of it actually detects pain, and that takes a specialized sensory stimulus and neuron to be able to detect that. Look at all of the other things that a sensory nerve can detect: touch, pressure, vibration, and temperature, which are not classified as pain. So your nervous system does far more than detect pain. In fact, pain is likely less than 10% of the functionality of your nervous system. Okay, so back to the integumentary system. Now you'll see these pictures in your textbook around page 99. So let's talk about the layers. First of all, when we talk about integument, we have to talk about the epidermis, the dermis, and the hypodermis. Epidermis, that word in and of itself should give you a clue. The prefix epi tells us that it's above or around. Dermis clues us in, so we're doing something with the skin. It is the outermost layer of the skin, and within it, we have multiple divisions and layers, which we will talk about in a second. The center layer is what we call the dermis. That also is comprised of a few different layers, and we'll walk through the layers as well as what constitutes the dermis and what's in there. And then the hypodermis, the prefix hypo, should clue you into the fact that it's below the dermis. So the epidermis is the outermost layer of the skin, which I mentioned. It in and of itself contains 5 layers of tissue, from superficial to deep, from the out to the in. The layers are the stratum corneum, the stratum lucidum, and that's in thick skin. There are 2 thicknesses of skin, thick and thin, and they have some contrasting differences to them. Within the thick skin, we have the stratum lucidum. That is not in every part of epidermis. Then the next layer in is the stratum granulosum, the stratum spinosum, and the stratum basal. All epidermal layers consist of cells, but none of them include a blood supply to provide nutrients to the skin. So being that the stratum basal is the innermost layer of the epidermis, it's going to come in contact with the outermost layer of the dermis. It's the one that's going to have some type of ability to do new cell production as well as nutrient transfer. As new cells germinate in that layer, that basal layer, they are pushed toward the surface and away from nutrients. The further they get away from that bottom or innermost layer of the epidermis, again, that's the stratum basal, the further the cells get from their starting point, the more likely it is that they will die off, because they won't have the ability to do the nutrient exchange. Most of the cells that we find in the epidermis are what we call a keratinocyte, which will be able to produce that protein we mentioned named keratin. Moving up through the spinosum and the stratum granulosum, the cells will progressively flatten and be filled with more keratin, which is what delivers the integument its toughness and water resistance. I mentioned that the stratum lucidum, this is only found in thick skin. Thick skin is only found in the palms of the hands, the fingers, and the soles of the feet and toes. Some of the attributes of thick skin is that we're not going to have sebaceous glands in these areas, right? We don't want thick oil produced in our hands or our feet. It will be slippery. Also, it gives extra protection to our hands and our feet. The stratum lucidum is a translucent layer that on a histology slide we would be able to evidence. The stratum corneum, which is that outermost layer of the epidermis, this consists of the dead cells that are farther away from that stratum basal. The epidermis completely replaces itself every 25 to 45 days. Now that's a pretty big window, okay, of cell replacement. So this system of cell regeneration has to be able to happen appropriately and constantly. Over the course of an average life, the epidermis sheds approximately 40 pounds of skin. That's a ton. Here is a great picture. It's in your book as well, but on our PowerPoints, you're able to see the different layers. Stratum corneum, outermost layer of the epidermis. Now, I do have an acronym for these layers, okay? Take away the word stratum if you're trying to remember the layers of the epidermis from the outside in. The acronym is this: cancel, grab some beer. So corneum, lucidum, granulosum, spinosum, and then basal. The melanocytes hang out in the stratum basal. Remember, the melanocytes produce melanin. These guys help protect us against radiation. Also, what is responsible for delivering a tan or a darker skin tone? Exposure to sunlight will cause the melanocytes to produce more melanin. As melanin granules are pushed out into neighboring skin cells, the skin will become tanned or darker. The presence of extra melanin in the skin functions as a sunscreen. So it is your natural inherent sunscreen, which is why sunburn is more likely to affect individuals with a lighter skin tone. An inherited condition called albinism prevents the normal production of melanin, and albinism is characterized by very little pigment in the skin, the hair, or the eyes. So an albino will have extremely pale skin and white hair. The epidermis also contains some specialized cells for immunity as well as the nervous system. And I think the way that this works is pretty nifty too. On this picture again, just let's look at it for a second. This cell here, this big blue cell, is called a dendritic cell. We see it hanging out in the stratum spinosum. This dendritic cell is a macrophage. So it's kind of hanging out, waiting to take care of any pathogens that might make it into this layer. Merkel cells is the name for this little yellow cell here, pointed out. It's hanging out in the basal layer. The Merkel cells, also called Merkel-Ranvier cells, they're located in the stratum basal, and they are touch receptors. So not pain, but touch. These cells form junctions with sensory nerve endings that will relay information about touch to the brain. Let's talk a little bit about alterations in skin color and what that can actually mean. Okay, skin is an amazing way to tell what is happening on the inside of the body. Now I want you to think about that. I'm going to give you a couple examples of what I'm talking about here. If you have, excuse me. Excuse me. Okay, I'm back. So The skin, okay, I want you to think about this. If you get the chickenpox, okay, you will end up with vesicles that show up on your skin. Little fluid-filled pimples, basically. Okay, this happens with chickenpox and shingles because they're the same viral infection at different stages. At any rate, what I want you to think through is the skin the site of the infection? The answer to that question is no. Okay. The viral infection is happening on the inside of the body. It is being represented or almost pushed out to the surface of your skin. Another great example would be hives. You may eat something and have an expression of hives on your skin. So your skin, again, it's telling you, it's forecasting or nowcasting what is happening on the inside of your body. You didn't have to touch anything to get hives, right? But something within you, you're having a response and it's pushing it to the surface onto the skin. Now, easier examples or the color of your skin. You can tell when someone has pallor or they're white and pale. Okay, their blood flow is not out on the skin. Their blood is being called to the inside of them to go to more vital places somewhere in their body. Same with someone with erythema. Okay, meaning you're a little flushed or red. Maybe you just went for a jog. Okay, again, the core body temperature has heated up and it is shunting blood to the surface or to your skin. This will also happen if you take niacin, supplement niacin. If it's not the right kind, it's going to cause a flushing to your skin. That might be a little uncomfortable and itchy, by the way. If somebody has liver damage, or you're talking about a baby that hasn't fully developed the function of their liver yet, we'll see something called jaundice. The skin, as well as the sclera or the white part of the eye, can also cause this. You can turn a little orange if you eat too many carrots within a short period of time. Okay, that's like a vitamin A overload. You're just not able to break that down. Okay, so let's talk into the dermis. The dermis is the middle layer of the skin, or what we call the true skin. It is a dense, fibrous connective tissue that's composed of collagen as well as elastic fibers. So collagen is a protein structure within our tissues that deliver strength and rigidity, whereas elastic fibers are thinner and elastic. They have something that delivers them the ability within them, within their structure and their shape, to spring back to original shape. The collagen fibers, like I mentioned, provide toughness, but they will bind with water molecules to help keep the skin moist. Elastic fibers help skin look young without wrinkles or sagging. During the normal course of aging, the number of collagen and elastic fibers in the dermis will decrease. The dermis has a rich supply of blood vessels, unlike the epidermis. This will help dissipate body heat or help maintain and retain heat. Within the dermis, we do have a variety of receptors that will communicate with nerve endings to transmit information about the body and what it's sensing and send it to the brain. We find here also a bunch of white blood cells called phagocytes, which then are distributed throughout the dermis and are responsible for ingesting foreign material, including bacteria and dead cells. The outermost layer of the dermis, I mentioned the dermis itself has a few layers, it has two, okay? The outermost layer is called the papillary layer, and this is named after the dermal papillae that protrude up into the epidermis, and actually this is what gives us our fingerprints. Some of the dermal papillae contain capillaries that supply nutrients up into the epidermis. Other dermal papillae contain nerve endings that will help with sensing, touch, and pain. Underneath this papillary layer is the layer called the reticular layer. The collagen and elastic fibers in this layer have an irregular arrangement. The reticular layer includes blood and lymphatic vessels, sweat and oil glands, and involuntary muscles, hair follicles, and nerve endings. Now, underneath the dermis, we have the hypodermis. The hypodermis, or subcutaneous fascia, includes a fibrous connective tissue as well as adipose tissue, that's fat. The lipocytes or fat cells reside within the hypodermis. Some amount of body fat is important for padding and insulating the interior of the body, and fat also serves as a source of energy, which we already knew that. Now, let's go through some of the supporting structures or accessory structures within the integument. Within the integument, we're going to have Pseudoriferous glands or sweat glands, sebaceous or oil glands, and we already mentioned hair and nails. Sweat glands or Pseudoriferous glands are distributed in the dermis over the entire body, with larger concentrations in the axilla, which is your armpit, on the palms and of the hands and soles of the feet, and also on the forehead. Each person has approximately 2 to 3 million sweat glands. The sweat glands will contain nerve endings that cause the sweat to form when the body temperature or external temperature is elevated. The evaporation of sweat from the skin surface is what helps with the dissipation of the heat so that it can evaporate, and this helps us in the cooling mechanism. There are two types of sweat glands. One is called an Equine gland, and one is called an Apocrine gland. The Equine glands are the major sweat glands of the body. They cover most of the body and open directly onto the external surface of the skin. So that's how you would know if you were looking at this picture, if you're talking about an equine sweat gland. So if you look at this picture, you can see the gland itself. It has a duct, so it has to be an exocrine gland like we reviewed in our last chapter, and it is dumping its contents directly on the surface of the skin. The sweat secreted by equine glands is a clear acidic fluid that consists of approximately 99% water, but also contains urea, uric acid salts, and vitamin C. Sweat itself is odorless, but if it's left on the skin, then bacteria can chemically change it to produce the body odor that we're used to, but it's really a breakdown of fatty acids. When bacteria break down fatty acids, that's when we have what's called bromhidrosis or BO. The apocrine gland, which begins to function during puberty, these guys are located in the genital area as well as the axillary region. The apocrine glands are larger than equine glands, and they secrete a milky fluid consisting of sweat, fatty acids, and proteins. Unlike these equine gland ducts, which again open directly onto the skin, the apocrine gland duct empties into the hair follicle. So you can see the difference here. The equine sweat gland directly onto the surface of the skin. The apocrine sweat gland goes into the follicle of the hair. A sebaceous gland, these are located all over the body, except, like I mentioned, for the hands and the feet. These glands produce an oily substance. This is called sebum. Most sebaceous glands will empty into a hair follicle, like we saw that with the Apocrine gland. And sebum will help keep the skin and hair soft, but it also contains chemicals that kill bacteria. When we talk about hair, we have to go through some of the parts of hair. Hair follicles are bulb-shaped structures within the dermis that produce hair. The base of the follicle is invaded by a papilla of connective tissue containing a rich capillary supply, which provides nourishment for hair cell formation. The matrix or growth zone within the base of the follicle will contain specialized cells that divide and generate living hair cells. Like those epithelial cells that were generated in the stratum basal, these cells are pushed up toward the scalp. They become filled with keratin and they die. Most of the shaft of hair is therefore non-living material composed mainly of protein. So what gives a person's hair a particular color and texture? Straight, wavy, curly. Melanocytes within the follicle will produce pigment that gives hair its color. As a person ages, the melanocytes will produce less pigment, resulting in gray or white hair. The shape of the hair follicle is genetically determined. A round hair follicle produces straight hair. An oval follicle causes hair to become wavy, and a flat follicle produces curly hair. Now, I will tell you that this can change over time. Speaking from personal experience, okay, as my hormones have shifted over the past 5 years, I now have very curly hair underneath the back of the underside of my hair. I had never had that my entire life. It was poker straight until the last 5 years, and now I have wavy or curly hair. So the chemical instruction delivered by your body can change your DNA, okay, to produce something else. So when we talk hair, let's talk about goosebumps. Goosebumps are part, excuse me, of an involuntary reaction when people are cold or frightened. There are tiny muscles that are called erector pili that connect on either side of the follicle to the epidermis. When this muscle gets stimulated, the muscle will contract and then the hair stands straight up. So the erect hair can trap a layer of air close to the skin and it helps just insulate the body. I think we know that though. When we talk about nails, underlying each nail is a specialized region of stratum basal known as the nail bed. The proximal end of the nail bed is a thickened region called the nail matrix. As with hair, nail growth occurs in the matrix, with new cells rapidly becoming keratinized and dying. Nails are transparent but appear pinkish in color because of the capillary supply under them. The white crescent moon-shaped region at the base of the nail, this is called the lunule. Its root comes from luna, meaning the moon. Okay, so let's talk through this slide just a little bit. As far as tattoos go, I personally don't know anything or much about tattoos. I don't have any. In order to, I would say, get a safe tattoo, you have to know what you're getting. You have to know the tattoo artist. And of course, there is tattoo care involved. I would say not just initially, you know, as we age and our skin changes, so will that tattoo. And I'm really not versed on the removal of a tattoo, but I know that it's not easy to do or likely that it gets done very often. If you want to read more about tattoos, that's on page 102 in your textbook. All right, so let's talk through a little bit of how the integumentary system develops. In the developing fetus, the beginnings of the epidermis and dermis are present by the end of the first month. Keratinocytes start developing at about 9 weeks. And at 13 weeks, differentiation of the skin layers begins to be noted. Hair follicles will originate in about the 14th week and sebaceous glands in about the 18th week. Equine glands at 23. By 34 weeks, the keratinocytes are matured and flattened. During the third trimester, a protective covering called the vernix is secreted by the sebaceous glands. This white substance is composed of lipids, proteins, and water, and surrounds and protects the skin of the fetus. At birth, a baby's skin will transition from continuous immersion in the mother's amniotic fluid to exposure to the air. This causes an initial dehydration of the skin, followed by increasing hydration for up to 3 months as the skin adapts. This increased skin hydration lasts for approximately the first year of the baby's life. Although at birth, the skin in full-term infants includes all 5 layers, the skin continues to develop functional capacities over the first year. The infant skin is in a constant state of flux with changes in hydration, lipid content, and skin acidity. The next developmental period lasts from infancy to puberty, and the skin of both males and females will thicken continuously during this stage. With the onset of puberty, hormones will exert a significant influence on the skin and the oils that are produced. Some of the hormones that we will see in this system are androgens. Our androgens will have an impact on the oiliness, the amount of oil or sebum that we produce. Females will have a higher accumulation of subcutaneous fat. That tells us that with higher concentrations of estrogen, that's what's happening. Yeah, I'll leave that there. Estrogen has an impact on bone growth too, but we'll hit that when we get to the skeletal section. Now, males will have a gradual thinning of the epidermal and dermal layers. And in puberty, we will notice a decrease in the skin collagen. So already stopping or breaking down. Now, as we age, there is a notable thinning of the skin with age. The more years you have on the planet, the less collagen your skin will produce and the less it will hold on to. You also, or we will also lose subcutaneous fat, which will create wrinkling and sagging. There may be an atrophy of the sebaceous glands, so skin and hair is just inherently drier. There can be an atrophy of the skin's blood vessels in the dermis, making it easier for bruising. And body temperature regulation also becomes a challenge with aging. As we talk about aging and then talking about hair and nails, We mentioned that hair follicles will be less able to produce melanin. Therefore, gray hair starts to come, and this can happen whenever. There's a reduction of hair growth in general. Okay, your body's not functioning on growing hair. It's saving all its nutrients for vital functions like making your heart beat and making your immune system hopefully work as well as it can. Baldness, you can have male pattern baldness, which is common with a large absence of hair on top of the head. Female pattern baldness is less common, but involves significant thinning of the hair to a point that the scalp readily shows through. Now, this can be I would say, a syndrome within many other disorders when people lose their hair. And again, if you take it down to nutrients and what the body's able to produce and has available to produce, the last thing it's going to look at or want to do is make hair. Nails grow more slowly, become yellow, brittle, or thickened. They definitely change in their composition. Sun exposure has been known to accelerate skin aging. That is due to the damage to the existing collagen and elastin fibers. As we have learned, also the decrease in the hypodermis fat or adipose tissue is a contributing factor as well. When we look at disorders of the skin, okay, the skin's pretty magical at renewing itself, as we learned, but we can notice a couple things that go wrong in the skin. One thing is called a Decubitus Ulcer. This is commonly known as a bed sore. It's a skin injury caused by an area of localized pressure that will restrict blood flow to an area of the body. Without the normal blood supply to provide nutrients and oxygen, the skin cells will die. So if you have someone that is bedridden, you have to move them, roll them, flip them, take care of their sores appropriately, because it can lead to other infections if the tissue isn't cleaned out and debrided. When we talk, and here's an example of a Decubitus ulcer, when we have, again, from the pressure and the laying and the lack of blood flow, these can get really bad. Now, burns. A first-degree burn, we've likely all had one. This affects the outermost layer of the epidermis, and to the degree of what layer it hits in the skin will deliver the degree of the burn. So like sunburn is a first-degree burn. Reddening of the skin, mild pain, and goes away kind of by itself. When we have a second-degree burn, we not only affect the epidermis, but also the dermis, and you'll get a blister, which will take longer to heal. A third-degree burn goes through the entire thickness of the skin. The skin may get gray or white or even blackened. It's initially not painful, but there is scarring and pain later, and it can't heal by itself due to the depth of the damage and how far down it goes. A fourth-degree burn, this is destruction of all layers of the skin and nerve endings, and it can even hit into the bone. Little to no pain, but it cannot heal on its own, and grafting and an artificial reconstruction will be required. When a large region of skin has been burned, clinician will use something called the rule of nines to estimate the extent of burned tissue. In this picture, we can see an illustration of what we're talking about here. According to the rule of nines, the percentage of total body surface area covered by burns is approximated as follows. 9% for both anterior and posterior head and neck, 18% for anterior and posterior torso, 18 on each side, 9% for both anterior and posterior of the arms, and then 18% for both the anterior and posterior of the leg, and 1% of the genital region. Using this approach, again, there can be an estimate of the surface area of the body that has been impacted by the burn. When we're talking skin infections can be caused by contact with an infectious agent that is present on another person or surface, but it can also come from airborne particles like viruses or bacteria, or a contaminated penetrating object. So viruses are extremely small. Also, they are not classified as living. It's actually like a protein capsule around genetic material. So, and we've, viruses obviously have gotten a lot of airtime in the last 2 years. There are multiple theories. I've mentioned that in previous recordings. Worth taking a look at the different theories pertaining to virology. We, the lay person, knows almost nothing about the science behind it. The way that they perpetuate themselves or reproduce, they have to have a host cell in order to make more of themselves, or it's almost like they're trying to repair themselves. An example of a viral infection would be herpes, or I mentioned chickenpox or the shingles. These are viral infections that hang out. Okay, viruses tend to hang out, even though they can be quiet inside of us forever or long periods of time. They tend to be detectable on blood tests and other things, even if they don't always produce a symptom. So herpes can produce a painful blister. Now this can be genital herpes or not, herpes simplex 1 or 2. Women get more infected than men. Men tend to carry it, women tend to get infected. That goes with several STIs actually. But even I don't know if that's true for a non-genital herpes. Okay, cold sores are a herpes viral infection. Okay, so variations of herpes virus is the chickenpox. Okay, you mentioned shingles, herpes simplex 1 and 2. Different types of vesicles. Again, is the infection right where it shows up? Not really. It's on the inside of your body. It's expressing in these fluids being pushed out onto your skin. HPV or human papilloma virus. This is what causes warts, plantar warts, genital warts, and regular warts. They can be removed, and you can get or topical medications. They're very common. There are some genetic tests that you can get done to determine if you have HPV or if you're even susceptible. Just an FYI. I think we know that washing our hands has, in combination with many other factors, one of the things that has changed over the century is understanding washing your hands or washing surgical tools. Just cleaning things off has been a big change. Sanitation has also been huge in the understanding of and control of communicable diseases, such as, a lot of these infections. When we get fungal infections, this could be like Candida. In this case, it's listed as tinea. Okay, found in moist areas. That could be in the groin. That could be in the feet, the toenails. More prevalent in warm weather. More common in those who have work activities that have a lot of sweating, or they can't get dry. Okay, so they give an opportunity for a fungal infection to occur. Now, if you kill some of your body's natural defenses against the balance of pathogens on board, sometimes fungal infections can take over. Okay, tinea pedis is athlete's foot, most common fungal infection, which is highly contagious, but you can get treatment and then work on prevention, like don't share shoes with someone. Tinea cruris, jockeyage, primarily affects males, can be spread through direct contact, but there is treatment and prevention. Tinea corporis, that would be ringworm. It's highly contagious, but there is treatment available for that as well. And then tinea unguium, this is the infection under the nails, not just the skin. Now, when we talk some skin infections that we see that are bacterial in nature, one of them is impetigo. This one is also highly contagious, and you can get pink or blister-like bumps. There is something called cellulitis. I think we've probably all heard that. It's an open wound or an ulceration. Okay, it can be life-threatening. And I'm going to say it doesn't necessarily have to be a wound. You can get a version of cellulitis just from maybe a hair follicle. You have a pathogen enter a hair follicle. Any inflammatory conditions, inflammation, I believe I've said it before, is a healing process of the body, and it's a function of your immune system, and it is highly required for it to work appropriately. Sometimes it gets a little out of control. We need to modulate it. It is your body's general response to anything of injury or disease. When we have inflammation, you will have an increased blood flow. So there's a whole chain of events that happen within an inflammatory response. Again, one of them being blood flow. If there's blood flow, the area is going to get swollen, likely red, going to be tender or painful generally. So we like to watch for signs of inflammation so we can see what the body's up to. Pleurisy is an inflammation of the pleura around the lungs, the lining around the lungs. The cause can be infection, cancer, rheumatoid arthritis, lupus injury, blockage in the blood supply, or inhaling asbestos. Pleurisy is painful, okay, and it's created by a friction rub in the membranes around the lungs. You can have pain that you can't quite get to. It's hard to get to, and fluid accumulation. And the treatment will depend on what created the pleurisy. Peritonitis is an inflammation within the peritoneum. The peritoneum is the internal abdominal cavities, kind of like the cavity and fluid-filled space around your intestines. It causes, or the causes could be the accumulation of blood, body fluids, or pus in the abdomen. And you would have abdominal pain, tenderness, and swelling. This can be life-threatening, and you would hope for surgery and antibiotics to be available and functional. One thing we can see show up on the skin is psoriasis. This is a common skin disorder where you have regions of thick red skin that gets scaly. It's an autoimmune disorder, though. It's not contagious, but it generally might have a epigenetic predisposition with a variety of things that cause a trigger. The treatment could be topical, systemic, or phototherapy. For psoriasis, they do say that tanning helps. Skin cancers. Okay, so skin cancers are named for the cells that they're going to impact. Malignant tumors can metastasize. It's the most common type of cancer in the United States, and they attribute it to the overexposure to sun. I would argue that. There are many things that can stimulate or catalyze the expression of a skin cancer. And if the skin does what we say it does, it shows us things working on the body. Skin cancer does not always show up in an area where you've been exposed to the sun. So one type of skin cancer is called a basal cell carcinoma, the most common, least malignant, slow growing and you can just have it removed. Generally, the prognosis is really good. A squamous cell, this is an overproduction of cells within that stratum spinosum layer. It will get scaly, reddened, and progress to an ulcer. The location will depend on the color of a person's skin. They grow rapidly and spread easily to lymph, and that's their danger. You can have them surgically removed. Radiation treatments are common for that. If you get a melanoma, this is a serious one. They're dark colored and irregular shaped. If they start changing size or a mole elevates, you might have a case of a melanoma and you want to get it fast. Otherwise, they metastasize easy and they don't respond to treatment like the other kinds do. So here is the ABCD rule to determine the presence of a melanoma. You want to watch for asymmetries, border irregularity, and the color of it. Even the darkness of the mole or whatever you're watching, look around it. If it has edges like outside of the dark melanin patch, if it's red there, you might want to get it checked and watch its diameter and how it grows. Okay, so indoor tanning. I don't think it's hard to understand that it's a high level of UV radiation in a short period of time. It can contribute to skin issues. However, like I said, they have noted that it can be helpful for someone with trying to manage their psoriasis symptoms. Okay, let's break down the words on this slide. Okay. So cutaneous, the word parts. Cutane, O is the combining vowel, that means skin. O-U-S is the suffix that means pertaining to. So the word means pertaining to the skin. Now, for your extra assignment this week, I want you to break down these word parts, hypodermis and melanocytes. I will post a separate little quiz for you to be able to do these two words. Have a great week. Talk to you next week.